Hi there, my name is Brett Westover, and I'm a solutions architect at Privacy Dynamics. Today, I will show you a way to create a copy of production data that has the personally identifiable information, or PII, removed, and then use that de-identified data in a development workflow. We'll use Argo CD to automatically deploy preview environments of our app, and we'll use Neon to host the data. Removing the PII from our production data before using it in developer environments helps protect our users. We'll remove things that directly identify our users, like their name and email address, and replace those fields with lookalike values that have no relationship to the original data. We'll then take it a step further and address the risk of indirect identifiers in our data. These are things like birth dates, the city they live in, or their zip code. These are things that could represent more than one user in the real world, but in our specific application, they may be unique. Imagine if we only have one user in a particular zip code. Even though we've removed the name and email address, it's still a unique user. If you had access to some public records or a leaked data set, you could identify which real person this is, and then whatever data we have about them is associated back to their real-world identity. This is called a re-identification attack. We can protect against this by not only removing the direct identifiers, but also looking at these indirect identifiers and modifying them as needed to make sure they can't be combined to create a unique user. With this level of protection in place, we can enjoy the benefits of using our production data for development and testing without the additional risk of a data leak that exposes our users. To demonstrate using real data in a developer preview environment, we'll use this e-commerce application. Starting with the data model, we have the users table. A user is identified by their full name and email address, but we also have their date of birth and gender. Each user can have one or more mailing addresses, which have street addresses, city, state, and zip, and there's a relationship back to the users table. We also have the products table, which has the ID and name of all of our products, and then there's the orders table. A user places an order for a product and ships it to an address, so the orders table ties all four of these tables together. The service we'll deploy is a reporting API that returns the information from this database. I'll switch over to it. When I call the user's endpoint, it lists all the users in the database. If I change this to return a particular user, it returns just that one user's information. So I have here Cordell Douglas. If I add /addresses to the end of that, it's going to return all the addresses for that user. And if I switch it to /orders, it's going to return all the orders for that user. This is the GitHub repository for the e-commerce reporting API we just explored. We can look here in the users API folder to see the source code for those API endpoints that we were using. And those are here. For example, there's the /users. Here's the /user/user ID. We also have some unit tests and some integration tests that I'd like to take a quick look at. The unit tests are for testing the API endpoints, and they can use mock data to make sure the endpoint is doing what we expect. There's also some integration tests here that rely on actual data in the database, so this app's tests won't pass unless there is data available. We also have an Argo CD server, which I've set up for this demo. The Argo CD server is designed to deploy one app for each pull request that is opened in that repo. The way it achieves that is through something called an application set. I've got an example of that in the repo as well. The application set uses what are called generators. A generator can be a couple different things, but in this case, we're using a pull request generator, which watches this repository for pull requests every 90 seconds. And when it sees a new pull request, it will deploy an app for it. And if it sees a pull request has been closed, it will actually remove that app. So the apps become ephemeral copies of this application for each pull request, sort of like a preview environment. When it deploys each app, it uses dynamic naming for the name of the app, which is e-commerce demo preview -number, where number is the PR number. So you don't get any conflicts between multiple pull requests being open. It also incorporates the number into the domain properties as each app gets a custom ingress. And it also names the namespace. So each app gets deployed in its own namespace, which also includes the PR number. When this app is deployed, it doesn't have some critical information that it needs that is dynamically generated when the pull request is opened. For example, our changes that we've just made in that pull request need to be built into an image and pushed to a registry. The image tag for the new build needs to be provided to the app in order for it to work. And it also needs some things like pull secrets for the private registry that we're using. And it needs to know how to get to the database branch that was created. That's handled in the GitHub workflow here. So the GitHub Actions workflow does a number of things for us. First thing it does here is it's actually going to log into the GitHub container registry, and it does a build and a push of the new changes. So you make some changes to the app, and you're actually going to get a new container image with those changes in it. Then it's going to actually use the Neon create branch action to create a specific branch in the Neon database for this PR. So every PR gets its own full copy of the database, which is a really cool feature. It captures the branch information for how to log on to it, and it also captures that image tag. And then it uses the Argo CD CLI to provide the image tag and the database URL to connect to that database to the app that was deployed. So the Argo CD application set automatically opens or creates a copy of the app, but it doesn't have this information that was dynamically generated in the pull request. The GitHub action creates that information and then sends it to the app, and the app heals itself to include that information. The next thing it does is it verifies that the preview is up and running. After it's been healed, it will have the image tag with the latest changes. It will have the database URL the app should be running. And so this just does a quick check to make sure that it is in fact running. Then it goes ahead and drops a comment into the pull request that gives you a clickable link to that deployed environment. Last thing it does is it actually runs those tests, both the unit tests and the integration tests that we looked at. If everything works correctly, you should get a green check mark, and you know that your changes are valid, that the tests still pass, and you can actually click through to that link to see the preview environment and your running application. Now I want to talk a little bit about Neon and why I chose it for this demo. Neon is a serverless Postgres provider that has a really neat feature called branching. Now you don't have to use Neon for this demo to work. It can use any Postgres database like RDS or Cloud SQL or even just a database container. But the thing that sets Neon apart is that it has a feature called branching. Branching is essentially what it sounds like. You can create a copy of your main database like you would create a branch in Git. When you create a branch, it uses a copy on write technique, so that creating a branch is cheap and instantaneous, and then it makes changes to its own copy, so it becomes independent. It's perfect for testing or for preview environments, which is actually called out specifically in their marketing and documentation material. I have over here the Neon console for this application, and I've got 3 branches currently. I have my main branch, which actually has those 4 tables that we went over earlier. And there's a fairly significant amount of data in here. I've got 150,000 addresses, I've got 1 million orders, 20 or so products, and I think 100,000 users. So creating a backup of this database and then a restore would take a little bit of time if we had to do that on on the creation of every preview environment. But with Neon, I can just create a branch, which is essentially instantaneous. So I've got a copy of the main branch in a new branch called anonymized. And this is where we're actually going to write the de-identified data with privacy dynamics. And then for each preview environment, we're just going to branch the anonymized branch again. So you can see here the parent of this one preview environment I have open. It has its own branch, which is just a copy of that. So this makes it really easy to just create a copy of the de-identified data for every branch and then just delete it when you're done. Now it's time to create the de-identified data that we'll use in our developer environments. I'm back here in the Neon console, and I'm looking at the main branch, and I can see that I have a connection string to connect to the main branch. If I switch to the anonymized branch, which again is just a copy of the main branch, I have a different connection string. And this is one of the things that makes working with Neon projects so easy, is that each branch is treated like a separate database with its own connection string. Privacy Dynamics operates off of connections, and I've gone ahead and set up a connection to the main branch here, and I've got a separate connection to the anonymized branch here. I'm going to click the green anonymize button to create a new project. A project is something where you set up the destination and origin connections, and also the treatment plan for what tables you want to treat and how you want to treat them. This is where we're going to create that de-identified data set. So I'll go ahead and select the neon main branch as my origin connection, and I'll choose the public schema. I'm going to choose a destination connection that is the anonymized branch, and I'll choose the public schema as well. Now, since it is a copy of the main branch, the data is already there, but we don't want that data. That data has PII of our customers in it. So we're going to just overwrite that. I am going to see some warnings here because the data already exists, but that's okay for this demo. The addresses table has PII, the addresses of our customers. So we're definitely going to treat that one. And you can see there's that warning. The orders table and the products table, on the other hand, these don't have PII. This is data that is associated to our users, but it doesn't have the PII directly in it. So we'll go ahead and pass those through. And then the users table, of course, this is the primary PII, like their full name and email address is in that table. So we're going to treat that one as well. Pass through is just copies it straight from the origin to the destination without changing it. On this next screen, I can choose my treatment plan. Now, there's a default treatment plan here where it's going to automatically detect the identifiers, and direct identifiers will be replaced, and indirect identifiers are going to be anonymized. But I'm going to use custom settings here just to make sure that we get what we want. In the custom settings screen, I can see in the addresses table that it has detected that the ID and user ID are primary keys and foreign keys respectively. So these are locked. Locked means it's not going to touch those. And this is important for maintaining the integrity of the keys between the tables. The street is a direct identifier because somebody's mailing address is a direct identifier to them. So we're going to replace that with a realistic value. Now, a realistic value means that in this case, an address is going to look like an address, but it has no association to their address. It's just essentially a faked value. And then the city, state, and zip code, these are indirect identifiers. They're about our user, but they don't necessarily directly identify a person. But in our data set, they could represent a unique record. So we're going to set those to anonymize, and that's where it's going to do the analysis to make sure that there are no unique records that could be created with the combination of these values. Again, orders and products don't have any PII, so those are just set to pass through. And then the users table, it's similar. It detected the primary key and it went ahead and locked that one. And then we're going to replace the full name with a realistic value, and we'll replace the email address with a realistic value. So those are fake values that look like email addresses and names, but they have no association with the original user data. And then similarly here, the date of birth and gender are about our users, but they do not directly identify them. So we're going to set those to anonymize, and it's going to do an analysis to make sure that we can't create a unique user out of those values to further protect them. So this treatment plan looks pretty good. I'm going to go to the next screen. I'm going to go ahead and give it a name. We'll just call this e-commerce demo. Now, in a production scenario, you're going to want to use the schedule feature. This is really nice because if you run the anonymization on a schedule, then you're refreshing your developer databases with new data from prod. It keeps it representative of your actual production. We don't need it for this demo, so I'll go ahead and disable that. I'm going to tell it to run immediately. And this last checkbox here is to automatically create data sets. In a database that is changing, you may have some new tables that show up. When they do, this will automatically add them to the project with the default treatment settings. We don't need that for the demo, so I'll leave it off here. And then I'll kick it off. Now, the addresses table has 150,000 addresses in it, and the orders table has 1 million orders in it, and there's 100,000 users. So this is going to take a few minutes. But as a reminder, what's happening here is it is reading the data from the source database. In this case, this is our main or production data, and it's going to write the anonymized copy to the anonymized branch. So we'll wait just a couple minutes. And it looks like it's done. So I'm going to take a quick look at the data sets that it created and see what the treatment result was. If I look at the addresses data set, I can see that it did what we told it to. The ID field and the user ID fields were locked since these are key fields. The street address was faked. And then the city, state, and zip, which are indirect identifiers, they were treated with the anonymization algorithm. It needed to change about 1% of the data in each of these cases in order to make sure that there wasn't a unique record. One of the benefits of privacy dynamics is that we use a surgical approach to change as little of the data as possible while dramatically increasing the anonymization in this data set. I can click on one of these and see what the change was in the specific values. And you can see that before and after, they line up pretty well with a few exceptions that were probably very unique. I'm going to go back and take a look at the user's data set to see how it did. The ID field was locked as we asked it to. The full name was replaced with a realistic value, and the email address was replaced as well. The date of birth and gender needed to be treated for anonymization, and it looks like it needed to change just a little bit of the data as well here to make sure that we didn't have any unique users. Now that the Privacy Dynamics project is complete, let's take a slightly closer look at the data so we can understand anonymization in this context. So we anonymized the addresses table, and our source was the main branch and our destination was the anonymized branch. So we can use the Neon console to take a closer look and see what actually happened to the data. So here's the main branch, which was the source of our data. And I've selected the addresses table, and I'm just going to take a look at some of these records. So if you pay close attention to the first, say, 3 street addresses here. Now remember, we told it to replace this direct identifier with a completely fake value. So if I switch over to the addresses table in the anonymized branch, which was the destination, you can see that these first 3 records, which they are the same records, but this field has been completely replaced with a lookalike value. Has no relationship to the original value, so it's been de-identified in that way. But if we take a look, and I'm back on the main branch here, at these first 3 cities, I've got this city, and this city, and if I switch over to the destination, those didn't change. And that's because we told it to anonymize those. Anonymization in this context means that it will look to see if the combination of city, state, and zip can be used to create a unique record, which could then be re-identified in an attack scenario. Because these ones were not unique, they didn't need to be changed. And that's the beauty of the anonymization, is that it doesn't need to change very much of the data. However, it does need to change some data in some cases if it does represent a unique record. So the first example here is our source data is this city here and this zip code 93429. In record number 10, if I go over to the destination and I look at record number 10, it's now 93455. It's a different zip code. It's nearby, so it is geographically aware. It tries not to move people too far away, but it did need to move this person into a larger group in order to not be uniquely identified. So that's an example of a precise field by field, what we call perturbing the data to make it anonymous in cases where the user could have been uniquely identified. So now that we have an anonymized copy of our database, we're ready to use it in our developer preview environment. The PII has been removed, which means we've eliminated a significant amount of risk should this data inadvertently leak during development and testing. Okay, that's enough talking about how this is all set up. Let's actually see it in action. So as a developer, when I make a change to this code, I expect to see a deployed preview environment with the anonymized data in it. When we called the user's endpoint, we got a list of all the users, and it was in pages, and those pages were 100 long. So let's say for one reason or another, we wanted to reduce the size of the page, maybe reduce load on the database, or have pages load faster. So I have here a change that I've prepared, and I'll just do a diff real quick so you can see what it is. Okay. So I have this page size variable, and I'm going to shrink it from 100 to 50. And then because my unit tests actually test the pagination and make sure that I'm selecting the right thing from the database, I need to change those tests as well to account for the fact that I'm retrieving 50 at a time instead of 100 at a time. So I'm going to push this up, and we'll see what happens when we open the PR. So we'll commit the change. Oh, actually, sorry, it's committed already. We'll just push it up. All right, now let's open a PR. Okay, so again, here's the change. We've got the page size going from 100 to 50, and then I updated this tests file as well. We'll go ahead and create the pull request. Now, when the pull request is created, it triggers that actions workflow that we went over earlier. It also triggers the application set. So the Argo CD server will see that there's a new PR here. It's PR number 9, and it's going to deploy an app. But when it deploys the app, it doesn't have this code change yet because it needs to be built into a container, and then we need to tell it what the image tag is. We're also going to create a branch of that anonymized neon branch specifically for this PR. So we get our own branch for the app. So let's take a look and see what the actions workflow is doing. So one of these is done. So it's going to build and push the container. So this is just a Docker build and a Docker push. It's actually going to pull in all the dependencies, and then it actually pushes it to the registry, and then it captures the tag that was created for this PR, and then it's going to create the preview environment. So first thing it's going to do is going to create a neon branch. So it's going to push that, and we can actually see it created over here. And there it is, it's already there, PR9. So this is a new branch that was created just now, and its parent is anonymized. So this is a copy of the anonymized data specifically for our app that is being deployed. Let's see what's next. The other thing is it's going to send the new tag, the image tag, and the neon branch URL to the app, and then it's going to verify that it's online, and that's done. And then it's going to drop the comment in the PR. So let's go back to the PR. We should see that comment now. We'll refresh here, and there it is. So the Argo CD app has been deployed. The workflow has ran and updated it with the new image, and then it dropped a URL for that environment. And we got a green check mark, so it's all done, which means the test pass. So if I click on this, now the root of this API just returns a hello world. So if I click this, I should just get hello world, and I do. I'll make that a little bigger. Okay, but if I call the /users endpoint, I get my data, and I should get only 50 of them. So my change works, and it is deployed. And now let's make sure that this is in fact our anonymized data that we created with Privacy Dynamics. So our first user here is Ivana Frank. So let's go back over to the Neon console and make sure that that is the same as our anonymized branch. So on the Neon console, I can go over here to my tables. I'm going to choose the anonymized branch. And if I look at users, yeah, the first user is Ivana Frank. So this is the de-identified data set that we're looking at in this app. Another thing we should take a quick look at is the actual app that was deployed in Argo CD as a result of opening a PR. So if I switch over here to the Argo CD interface, I can see my one app is deployed, and it includes the PR number. So this is preview 9. I can see that it's healthy. If I click through, I can see the components that were deployed. And one component of particular interest is the e-commerce ingress. This is also includes the PR number. And this was where the link that was posted in the PR came from. If I click this, it's going to go to that same Hello World landing page. And there it is. Using preview environments is really easy for developers. They just open a PR, and then they get to see what their change would look like in the running app. They get confidence that the app will build and can be deployed. By adding real data from the production environment, they can see how a new feature will look and function in a realistic way, and they're much more likely to catch bugs that may be triggered by real-world data. At the same time, your customers have been protected by anonymizing the data before using it for development and testing. Thank you for taking the time to check out this demo. If you think your developers would benefit from better data in their testing and preview environments, come and see us at privacydynamics.io.